And I'm going to share the screen. And we need to go to the Jupyter. Oh. Actually, I'm just going to leave this. All right. Okay, so what do we need to do? So let's start fresh. So the other thing I want to do is I want to have a new Jupyter notebook for this one. Okay. So we're going to build probably a Celsius to Fahrenheit calculator or equation, however you want to call it. So since we're done, I didn't really give this a name, so maybe I'm going to rename this and call it Tensor Basics, Torch Tensor Basics. Okay, I'm going to hit rename, save it, so that one's done. Now that I'm done, I'm going to close it. And usually, if you notice, there's a little tab here called running. You can click on that and just click shut down, and it'll shut down that Jupyter that you were running. Might, if your battery and things like that might consume less energy. All right, so I turned it off. Go back to files, and now you can see that in my folder, I have one Jupyter, which is the one we just completed. Now we're going to start a new one, Python 3. Gonna add some cells in here. And as I said, we are going, let's give it a nice proper, let's be like good programmers, right? And let's provide information. So I'm going to say build a Celsius. Is that how you spell Celsius? To Fahrenheit. What do we call this? Calculator, why not? Model, let's say model. AI model, why not? Sure. AI model, how about that? Very fancy for something very simple. All right, now don't forget, you can do very interesting things. So one of the things we can do is make the cell here, markdown. Okay, I'm gonna hit run. Now, another thing I might wanna do is, how are we going to learn, right? So how are we going to build this calculator? So let's go to the whiteboard. Add a new one. Okay, so what we're going to build basically is an equation. A lot of machine learning is basically that. It's equations, right? We're always trying to build an equation that takes inputs and gives us an output. The general formulation of it is y equals w times x, this is times multiplication, times x plus b. Do you see that? That's an equation, which means what? You give it an input and it gives you an output. Do you see that? That's very much what we were doing before, right? So you give it x and it gives us y, but this is a very simple thing called a linear function, okay? And what is this w and what is this b? Well, those are usually called the parameters or the weights, and they're the thing that's the learning, right? So the model needs to use some techniques to learn what these variables should be, okay? Once we've learned the appropriate w's and b's, then given x, we will be able to correctly predict y. Do you see that? That's the general idea. And that's what machine learning is, basically. It's just that these equations get really big, right? But it's in general the same idea. This x can be a vector, right? So what that means is, remember how we had for the furnace 10 features, 10 inputs, x1, x2, x3, right? So then that means that this just becomes w1 plus w2 plus W3. You see that? So we have to now learn a weight for each of the inputs. Instead of just learning one, we have to learn for this X a weight, for this X a weight, and for this X a weight, plus the bias. Got it? But that's basically what we do in machine learning is we're running the algorithm constantly and trying different weights, right? And then we try the weights and they give us a value. And if the prediction is good, we kind of like, okay, stay with those weights. Otherwise, if the prediction is bad, we change the weights to another set and so on. So there's more to it, but that's the general idea. Any questions? All right, so that's what we want to do, right? So our general model then, we have agreed that will look like this. Okay, so we will need to set up some variables for X. You know, that's why we did the word problems, right? We started with X, with Y. So we need X's, we need Y's, we need W's, we need B's, and then all of it needs to work together in our model. Got it? All right, so let's go ahead and start. So, I'm going to go back to the Jupyter Notebook. Okay, we go back to the Jupyter. Could probably move this one up again. Okay, now let's rename it. Let's get into the habit of renaming things. So this is going to be temperature, no, this is not temp. This is Celsius to Fahrenheit. Right. Now we'll know that it worked because we give it some Celsius temperatures and we should be able to know what a Fahrenheit is, right? So it should generalize well if we train it correctly. Okay, so let's also add a note here. So I'm going to make this a markdown, and I'm just going to say $sign. I think this should work. Y equals W asterisk, which stands for time, X plus B. Right, so I think that's, yep, there it is. So this is, what I was saying about using Jupyter notebooks are really great because you can also add your notes, add equations, add pictures, all kinds of things to make this almost like a report with the code and everything. Right, so this is just an example of that. So that's the function that we want to use. And now let's go ahead and start thinking about, so we need to write this equation in, we need data, and then we need to train the model and find all of these variables, okay? And then there's actually several ways of doing this. We're just going to take a very basic from scratch approach. So please, also, if you have any questions, stop me, right? So if you want me to address something. So let's gonna do import torch, import numpy as np, and actually I'm going to import matplotlib. Matplotlib dot pyplot as plt. Okay, so this is for graphing and things like that. Is really nice. So hit enter or run, sorry. Gives me an error, right? And that means that we haven't installed this library, but I showed you guys already how you can address that. So we do exclamation pip install matplotlib, right? Go ahead and hit run. And Let's give it a minute. After that, we're going to need some data in Celsius and Fahrenheit. Still doing it? So my computer is a bit slow. All right, so while it's doing that, I guess we can start writing in the data. Okay, so let's go down here to a cell. So we're gonna have, we need data, right? Celsius to Fahrenheit. What do we need? We have the Celsius value, the equivalent Fahrenheit value, right? That's your word problem right there. That's what we need. Since I'm gonna type it in, I'm just gonna have 11 samples, okay? Which is gonna be the Celsius to the Fahrenheit. Okay, so it did finish, so I'm gonna go ahead, comment it out. Okay, so matplotlib should be there now, so it should be loading. Let's now create the data. Gonna make this a markdown as well. So I'm gonna say, I'm gonna start with, call it the inputs, actually. And the inputs are going to be Celsius, okay? So I'm just gonna say TC for Celsius, and it's gonna be a Python list. And then the outputs, well, that should be TF, right? TF for Fahrenheit. So that's like that. So then let's add a few values. So 0.5, comma. Actually, I can copy this from here, so I don't have to type all of that. So I'm just going to copy this data, okay? So that way I can speed up a little. Okay, I'm just going to change the variable name. So this is going to be TF instead, because it confuses me, that TU there. All right, so one is Celsius, one is Fahrenheit. Okay, guys, everyone with me? If you notice, it makes sense, right? Because what is the freezing point? 0 in Celsius, 32 degrees in Fahrenheit. This is roughly 0 to 32. You can see it over here as well, 3 to 33.9. Now, keep in mind, we're going to be learning from data, right? Data is noisy, okay, all the time. Maybe you had a sensor and the sensor sometimes failed, it had interference, whatever. So there's going to be some randomness always in the data. Actually, it's something that you want in a sense, and that's, it could be there, right? So it's not perfect, but because we have enough samples, the model should learn to predict okay-ish. Obviously, the more data we have, the better. Got it? Everyone with me, guys? So like this 21 Celsius corresponds to that 68.4 Fahrenheit. Okay? All right. So it doesn't seem like you have questions. So now I'm going to go ahead and hit, and now I've loaded the data. Okay? So now what do we want to do? Obviously, those are Python lists. We want to convert them to Torch tensors. but we've done this so many times that you guys already know how to do that. So we're going to say TC underscore, no, TC underscore T again for torch, okay? And we're going to say the same TF underscore T for torch again. So that just means we're converting things to torch. We invoke torch dot tensor. And it's TC here. And then this one is torch dot tensor. And that's going to be TF, right? So we're just going to convert them. And then if you can print them, I'm going to do print TC T and print TF T. Okay, so I'm going to hit run. And you can see the values have now been converted to torch tensors. Okay, so we've got our data, made a lot of progress there. We may want to plot the data. Okay, so to plot the data, we are going to use matplotlib. We called it PLT, so we can make a reference to that. And I'm going to say PLT dot plot, where we need to provide the data, right? So that my data is in these two tensors. One is going to be on the x-axis, one is going to be on the y-axis, basically. So you can just provide them. Here's x, so this would be like x-axis, y-axis, right? Okay, so then it's going to be the Celsius data and the Fahrenheit data. So T underscore C underscore T. Now we have our first problem. Matplot wants NumPy arrays, but we've already converted these into torch tensors. So what do? Dot NumPy, right? There you go. That's why we have dot NumPy. See how handy that becomes? We just use dot NumPy and now problem solved. Then we do the same TF underscore T dot NumPy. Like that. Okay, and then we might want to specify the symbol that we want to use. So we can say O. Okay, O. All right, now we're going to do plt.show. And hit run. And there it is. That is your data and in a visualized way. So if it's 0, right, it's like 32 probably. So you can see it's Celsius to Fahrenheit. 25 is like 70, it seems. 25 Celsius to 70 Fahrenheit. So this is our model, basically, that we want to build. An inference model using that linear equation, where we give it 0 and it gives us 32. But we need from the data to learn what the values of W and B are. And this is pretty much what we will be doing all the time with deep learning. It's just that the models get much bigger, much bigger. But in essence, we're all, yeah, please go ahead. Yeah, so the O is just for graphical purposes. Yeah, I think, for instance, just to give you, I don't know exactly, but if you use S, it should give you a star, I think, maybe, or square. There you go. It just changes the little shape of it. You can do lots of things with matplotlib, so beyond this. Got colors and all that. Got it, guys? Any questions? All right, so We visualize the data. You can put titles and, you know, axes and all that. I leave that as an exercise for you guys to do. Because what we want to do before class ends is build our inference model, right? So we want to build it. So I don't know if we'll have enough time, but I'm trying. I don't want to rush it either. All right, so we've looked at the data. Now we want to create our inference function, right? So a lot of things in PyTorch, etc., are object oriented, and they're definitely functions, etc., right? So we can define a lot of things as a function. So I'm going to go ahead, and this equation up here, right, is going to be what I'm going to write here now in the PyTorch code itself. Okay, yeah. So I'm going to create it as a function. So this is usually you want to call the thing that given X gives you Y the model. Okay, regardless of how complex it is, it's just a standard thing to do. So that's your model right there. What does your model take here? There's a couple of ways that we can write this, but it takes basically the Celsius in this case. Now, it can also take the W and the B, because if you notice, to get Y, you need these three variables, basically, right? So you can pass them to the function itself. So let's try that approach. So I'm going to say TC for Celsius. This could be one, because we're dealing with tensors, this could be one value. It could be 300 values all at once, a batch, right? That's no problem for PyTorch. So W and B. Okay, guys? So those are the parameters that we can pass to the function, colon. And now we're going to do return. And what do we return? W times what? Huh? What is X? TC, right? T underscore C. Yeah, very good. Plus B, correct? So we know this will do it. But the problem we have currently is we don't know what W and B is. We don't know it. So we got to discover that from the data itself. So how will we do this? We usually have to run in a loop, right? So there's a couple of elements that we need. We need basically in machine learning all the time, we need the inference function, which is the thing that given in data gives you something. We need something called the loss function. And this is something that may be new to you, but it's like the objective. What is it that this AI is supposed to do? You know what I mean? In this case, this AI model needs to do what? Predict good values, right? So it's got the real values, and then it's going to have whatever it predicts. So what it's going to do is it's going to compare its predicted to its real, and it's going to try to minimize that error. Okay, that's really the objective. Everyone with me, guys? Over there, everyone with me? Easy, pretty easy. All right. So we got how many minutes? 11 minutes, right? I'm rushing here. We may not be able to finish. All right, let's see if I can. So the next thing we need to do, so we will need the loss function here. And then we also need what is called the training loop. And the training loop is like a for loop. And what that for loop does is it's going to take a real value, run it through the model, predict, right? And kind of try to update the weights. You update the weights every iteration until you arrive at a good set of weights, okay? You know, what we're looking for is to learn what W and B should be. So we're going to call this the training loop. Training loop. Okay, so I'm going to do cell, markdown, run. Okay, just a little heading there. I haven't defined the loss function because I want to go back to that and leave it last. Kind of motivate what we're doing here. So the training loop is also a function. Sometimes it is in this case. So in the training loop, we are going to need several parameters. We need something called the number of epochs. Now, keep in mind, this thing that I'm doing right now is the general template. that you're going to repeat all semester. It's just some parts will become more complex, etc. But we are always doing almost these three things. All right, so n epoch is the number of times that you're going to show the model the data. Learning rate. Learning rate is another thing that's very interesting. We'll talk about that in a sec. And there's we'll do several lectures actually for that. Params. Param is another name for the W and the B. Sometimes you want to hold the W and the B in a single thing, like an array. And so you usually call it parameters. Okay. So that's another term there. Then the data itself. So that's going to be T right? And TF T. Okay. Now this is not the same as the other one because these are arguments within this function, but it doesn't matter. We can use the same name. So now comes the magic of machine learning. This is kind of how it happens in general. You're going to repeat in a loop, right? A process. N epochs is the number of times that you repeat it, basically. So we're going to say for this data is very easy, so 100 times is probably enough. But you always have this for loop, for epoch in range from 0 to n epochs, where n epochs is like 100. So I'm going to repeat this process. So what do I need to do? I'm going to predict basically every time. So we usually call that ypred. Okay, so this is the idea of getting y, right? So we give it x, we give it the parameters, it gives us y. Now we already created this function and we called it model, remember? Remember, guys? So then we can just invoke it here. So I'm going to say, model. Do you see that? So now what I need to give it is the data itself. So in this case, it's going to be which one? TCT or TFT? TCT, right? Because we're trying to predict Fahrenheit from Celsius. So TCT. You see that? We also need to give it W and B, but we're going to be using this variable called params. So we just give it like this, params. This allows us to access the data individually. Now, I haven't created this variable yet, okay? But it's basically the W and the B, okay? So what this is doing is, because if you notice in model, it takes two things. So it's like we're breaking it up into the two things here, okay? All right. So given Celsius and the parameters, we predict Fahrenheit, correct? So I'll kind of have to just like wrap up here because we're not going to have enough time, unfortunately. We'll finish, and we have Labor Day. So it'll be 2 weeks, but yeah, sorry. All right. Anyway, so we've got the model. We obtain ypred, and then what do you think we need to do now? So the model given X predicts a Fahrenheit. So in your mind, what makes sense to do now? We've predicted a Fahrenheit, and what do we want to do? We want to compare it to the equivalent real Fahrenheit for that Celsius. Do you see that? And probably when the data is at the beginning, that's a really bad prediction. But it's going to give us an error, right? So the difference between the predicted and the real is going to be pretty big. And we can use that information to adjust the W's and the B's until eventually the prediction of Fahrenheit is going to be pretty good. And that's the objective, okay? So we need to capture that in some way. So to capture that, we do something called loss. We need to define loss Fn, where loss Fn is going to take what? It needs to take ypred, right, which is the predicted, correct? The order here doesn't matter. And what else does it need to take? TFT, very good. TFT. Oops, lowercase, right? Because that, oops, why is it? Because it needs to compare the predicted to the real. So then what is loss FN? So if you remember, this is the thing that I didn't define. So now I can define it. So I'm going to say define loss FN. And here I'm going to say Y real. See, I can change the names. Y real, Y pred. These two values, they can be individual values. They can be vectors. They can be batches. So if I have 16 predicted and 16 real, that's fine. You see what I'm saying? It works fine. So now what do? I need to calculate. This is called the minimum squared error, MSE. We'll look at this theory a little bit later in a lecture, but that's why it's good to have taken a regression class or a stats class, because you would have seen that there. But otherwise, we'll talk about it. At the end of the day, the idea is that you're going to compare the Y real. Oh, oops, sorry. Keeps making uppercase. The Y real, so I'm going to put this in parentheses. So it takes the difference between the Y real and the Y pred. You see that, guys? Oh, yeah. Should be Y real, right? So let's say that it predicted Fahrenheit 43, but the real Fahrenheit was 25. So that's a big error, right? So that means the W and the B is not very good yet. But after a lot of repetitions, the W and Bs are gonna be so good that it predicts 26 and it's 25. So it's minimized that error. Got it? All right, so that's the idea. Now, we usually hear square it, and that's just because sometimes you might have 5 minus 3, or you could have 3 minus 5, and the sign is going to mess up things. But when we square it, we don't have that issue. Okay, so then we do this and call this one squared diffs, basically. Now, if we send 10 predicted and 10 real, then we have 10 samples, right? So we have 10 differences. So we want to take the mean of all 10 to arrive at 1. Do you get that? And so that's what I'm going to do here. This last part is squared diffs. And then because since this is a tensor and this is a tensor, then this will be a tensor, which means that we can use tensor functions. So I'm just going to invoke mean, and it gives us the mean. Do you get that, guys? And all right, so it's 7:49, unfortunately, so we're going to have to stop here. But we made good progress. That's basically the loss function. We're not done with the training loop yet, so I still need to finish it up a little bit, and then we would train the model. If you'd like, it's not homework, obviously, because you will have the NumPy and work problems homework, but you guys can try this one on your own. Yeah. You want me to do the, yeah, okay. Sure. I can do that. I don't think.
Thursday?
Huh?
Or this will be up like Thursday?
What will?
The next recording, you'll get the class.
The other, I don't think I'll finish because it's gonna run the same time, right? Unless I speed up over there, but I'll try. But I understand exactly what you said, so I'll try to do that. Yeah, I see what you're saying. So I will definitely upload the video, but yeah, it's 7:50, so I gotta stop. So we'll stop here. Let me stop the video.